Guys, in this video we will discuss about the homogeneous function for multivariate function, and here we will try to find the degree of the homogeneous function. So see here that here we consider one function where u is equal to ax square plus 2hxy plus by square, and now we are trying to find the degree of this multivariate function, and see that here u is the dependent variable, here u is the dependent variable, and x and y are the independent variable. X and y are the independent variable. So now the question is that how can we obtain the degree of this multivariate function? So now we can obtain the degree of this function by two ways. So now see here that how can you find it? That we can write that if we write u is equal to ax square plus 2hxy plus by square. So now we can say that this one is the function that we can write it, that if we take x square common, then we can write a plus 2h y by x plus b into y by x whole square. And from here we can write it like is of the form x square into phi of y by x, where we consider this function as a function of y by x. And from here we can say that the function, and what is the degree, what we take the of x, that is 2. And also similarly we can write that u is equal to, if we take common y square from here, then we can write it a into x square by y square plus 2h x by y plus b. And also we can write it like y square into psi of x by y. And here the power of the common term, that is y square, and here x, that is the power of the common term, is 2, and this is known as the degree of the homogeneous degree of the function, or degree of the homogeneous function u is equal to ax square plus 2hxy plus by square. So we can say that this function u is a homogeneous function of degree 2. U is a homogeneous function of degree 2. And now for related this homogeneous function, there is a theorem, that is Euler's theorem. So what is the statement of, and now we will going to discuss the statement and proof of the Euler's theorem, and then I will show you one example regarding the Euler's theorem. So now I just give you the statement of Euler's theorem. So what is the statement of Euler's theorem? Then here if we consider a function f of xy, we consider a function f of xy, and this is a homogeneous function of degree n, is a homogeneous function of degree n, is a homogeneous function of degree n, then we can write that x del f del x plus y del f del y is equal to nf. This is the statement of Euler's theorem, that is if f of xy is a homogeneous function of degree n, then we can write that x into del f del x plus y into del f del y is equal to nf. So now let us try to prove the statement of this theorem. So now let us solve on the proof of this theorem. So what is the statement, and what we have to prove? That in the statement given that f of xy is a homogeneous function of degree n. So now we can easily write that since f of xy is a homogeneous function of degree n, is a homogeneous function of degree n, then we can consider that, or we can write it like f is equal to x to the power n phi of y by x. F is equal to x to the power n into phi of y by x. So now, and in the statement given that x into del f del x plus y del f del y is equal to nf. So now let us try to prove this statement. So now for proving the theorem, we have to first differentiate it partially with respect to x, and if we differentiate partially with respect to x, then what we get? That is del f del x is equal to, here we have to use the the formula of the product of the two function of derivative, that is we get here n x to the power n minus 1 phi of y by x plus x to the power n phi dash y by x into minus y by x square. And now, and if we simplify, we will get n xn minus 1 phi of y by x minus x to the power n minus 1 phi dash y by x into y. And now if we multiply, now if we derive this function again with respect to y, that is del f del y is equal to, we will get x to the power n phi dash y by x into 1 by x. And now I just give it number 1 and we just give it number 2. And now if we multiply 1 by x and 2 by y and then adding, what we get? That is x del f del x plus y del f del y is equal to n x to the power n phi of y by x minus x to the power n phi dash y by x into y plus x to the power n y into phi of y by x. And see here, both these terms are cancelled out, and from here we can get x del f del x plus y del f del y is equal to nf, whereas f is equal to, we consider x to the power n into phi of y by x. So now this is the proof of Euler's theorem. Now I will show you one problem, that how can we use the Euler's theorem in multivariable calculus. So I just show you one problem here, that here if we consider one function, that if u is equal to tan inverse x cube plus y cube by x plus y, then show that x del u del x plus y del u del y is equal to sine 2u. So what is given? That u is equal to tan inverse x cube plus y cube by x plus y. So from here we can write that tan u is equal to x cube plus y cube by x plus y. And now see here, from here we can write, if we take common x cube from the numerator, we can get 1 plus y by x whole cube and divide by x into 1 plus y by x. See here, now we can write that x square into phi of y by x. And what is phi of y by x? That is 1 plus y by x whole cube divided by 1 plus y by x. And from here we can say that the function tan u is a function, is a homogeneous function of degree 2. Homogeneous function of degree 2. So now the question is that now we have to prove that x del u del x plus y del u del y is equal to sine 2u. So now here the tan u plays the role of f. So now from the statement of Euler's theorem, that now we can write x del x of tan u plus y del y of tan u is equal to 2 tan u. And if you consider the statement of Euler's theorem, that x del f del x plus y del f del y is equal to nf, see that here tan u plays the role of f. Tan u plays the role of f. And now we have to find the partial derivative of tan u, and from here we can write that x into sec square u del u del x plus y into sec square u del y is equal to 2 tan u. Now multiplying both sides by cos square u, we can write x del u del x plus y del u del y is equal to 2 tan u cos square u. And if we simplify, we will get 2 sin u cos u, and from here we can write sin 2u. So we can conclude that x del u del x plus y del u del y is equal to sin 2u. I hope you understand this topic. So thank you.